Okay, today we finally start trigonometry. All right, this class is called Trig Pre-Calc, but we haven't touched trig all year, and now we're diving in. Chapter 4 and Chapter 5 are a pretty in-depth approach to trigonometry. Trigonometry is just kind of a good way to explain it is geometry meets algebra and the coordinate plane. That's what trigonometry is kind of all about. Okay, all right, so we got to build a foundation here of some of these terms today. I don't plan on getting too far today. I just want you to fill in this first page of notes and submit that online. All right. So the initial side of an angle, I want you to write this in. It's going to be the starting position of the ray. That's always going to be called the initial side. Another word for initial is beginning. Okay. Another word for terminal is ending side. So the terminal side is going to be the ending position of the ray after rotation. Okay. So initial side is the starting position of the ray. Terminal side is where it's going to end after it rotates around whatever direction. Okay. All right, we'll use some of these geometry terms. As I mentioned before, trigonometry is a little combination of some geometric standards. All right, so if an angle is acute, let's write an inequality for this. And this is a symbol used quite a bit for angles. Maybe you remember it from Algebra 2. It's called theta. It's just like, it almost looks like a fancy capital O. You just kind of do this and then finish with a little fancy swing to it. I don't know what you want to call it. Okay, so theta is greater than 0 degrees and less than 90 degrees. Okay. All right, now before we put in radians, I'm going to skip ahead here to the straight angle, then work my way back. And I'll go in a little more detail on page 2, how I get all of these common conversions, common angles and radian measurement. I'm not ready yet, so let me just give you a couple facts about straight angles. In degrees, should be obvious if you remember this from geometry. It's like a half turn, right? 180 degrees is a straight angle. In radians, that's actually equal to pi. And so for now, just start working on memorizing that fact. I'll give you a little more elaborate explanation later. Okay, so that leads us to half that, right? Because if 180 degrees is our straight angle, we know our right angle is 90, and then that helps me figure out what this is going to be. Since this is a half relationship, well, in radians, then it's going to be half of pi. So we call this pi over 2. Okay. All right, that's why I want to cover that first. But so now I can write the acute angle in radians, because now that I know 90 is pi over 2, I'm just going to replace that with pi over 2 here. So in radians, we'd say it's greater than 0 radians and less than pi over 2. Notice I didn't put the degree symbol. You shouldn't have it. Okay. All right. Obtuse angles, those are the ones that are bigger than 90, but not more than 180. So we'd say the angle is going to be, I'm going to try squeezing this inequality. Sorry. So theta is greater than 90 degrees and less than 180 degrees. So if I were to write that in radians, look to what we called 180 over here, right? 180 is pi. So it's going to be less than pi, but greater than pi over 2. Okay. Pause if you need more time. All right, now positive angles and negative angles go in different directions. And just a little reminder too on quadrants. Quadrant 1 is always in the upper right, and then we name quadrants going counterclockwise. So this is quadrant 2. We usually use Roman numerals for these as well. Quadrant 3 and quadrant 4. Okay, we don't have to label them for all of them. I think once is enough. So a positive angle always rotates through the quadrants in order. All right, so our initial side, typically our initial side is always going to start at the positive x-axis. It's called the standard position. So it's going to rotate this way through. Negative angles are going to rotate backwards through the quadrants. So maybe just draw a directional arrow showing that. Negative angles go clockwise. Maybe you want to write that too. Positive angles counterclockwise, negative angles clockwise. Okay. Same thing over here. We just labeled it so that you get used to these. 90 degrees is pi over 2, as we wrote down up there, and that's pi over 2. So it's still going to rotate same direction if it's in radian measurement for positive and negative angles. Okay. Let's take a look at this first set of examples. Sketch each angle in standard position. Okay, so standard position, it's not defined in here, so let's define it right here. Standard position means initial side is on the positive x-axis. Initial side is on the positive x-axis. And then state the quadrant where the angle terminates in. Okay, so if the initial side is going to be there, here's what I want you to do for number 1. We're going to draw the vertex right here, and then I know it's a line on top of a line, but if you just kind of darken it in, and maybe even go a little bit further past it, you can see how we started right there. Okay. All right, so if we draw 215 degrees, we don't have to get a protractor out and get crazy here. It should just be about the relative position as mine is. We should be about the same spot is what I'm trying to say when we estimate this, okay? All right, so we're going to rotate this in a positive direction, okay? So this way around, counterclockwise, and then just do some basic math. We know a straight angle is 180, and that's pretty close to 180, just a little past it. So you always start with a little directional arrow. Okay, so I've traveled 180 degrees so far, so I just got to do the math. What's 215? Take away the 180 I already rotated. Okay, and the answer to that is 35 degrees. All right, so I just have to go another 35 degrees. So if I know each quadrant's 90 degrees, that's just a little over a third. So like I said, just estimate that. What would a little over a third look like? Draw an ending arrow, and then extend your terminal side about a third of the way through that quadrant. See how much? A little below half, basically, or maybe I'm almost closer to half. Maybe I should have bent it a little more this way. That's why we should use pencils, right? Because now I have a sloppy angle. All right, so there's an approximate 215 degree angle. State the quadrant the angle terminates in. This is quadrant 3. Okay. All right, I'm going to try a pencil for number 2. Since that was messy, I should have erased it and maybe flattened it out a little bit. All right, so now it's a negative angle. So negative angles, once again, we got to start on the positive x-axis. So let's draw the initial side here. And now I need to go backwards through the quadrants. Okay, so negative 180 would take me all the way over to the other side, and I'm 30 degrees short of that. So that's one way to think about it, or maybe you want to think 90 and then 60 more to get to 150. But 30 degrees short of a straight angle. So I'm going over here, and I'm stopping about 30 degrees short. Okay. The directional arrows are important because if I had the angles going this way around, that's a positive angle. Okay. So start and finish. This one happened to end in quadrant 3 again. Okay. Let's stick with the degrees right now, 5 and 6. I want you to pause the video and try 5 and 6. Okay, you might not have known what to do with an angle greater than 360, so let me explain. We're still starting here. When you rotate something more than a full rotation, which this one clearly is, you kind of expand the inside of this directional arrow. Okay, so see how I'm kind of creating a snail-like effect or nautilus. So I just rotated 360 degrees, so we just have to figure out what's left over now. So if I take 360 away, I'm now left with 140 degrees. So now that's what I have left to do. So now I do the 140 just like I did 1 and 2. So 140 degrees, well, this is 90 more. So if I take away another 90, okay, I'm left with 50 degrees. Okay, so I just got to go another 50 degrees. It's going to be about halfway through this quadrant because 45 degrees would be half. So something like that. Okay, the directional arrows are important. So show here that we ended there, right? Because this is where you started and then this is where you ended. Otherwise, if it's not there, I don't know if it's the other way around. Okay. All right, so there's 500 degrees. Quadrant 2 is where that lies. So number 6, negative 395, starting here. Go in the other direction now. Start expanding it because we're going to go past a full rotation. You can ignore the sign when you're doing the math. Just think 395. I just did 360. So what's left? I just have 35 more degrees to rotate. So 35 more, about a third of a quadrant, roughly speaking, somewhere around there. Okay, this is in quadrant 4. Okay, we're going to wait on the radians until I give you some more detail on how to convert those. So for now, today we just wanted to focus on these terms, getting used to those, the direction, and rotating these angles in degrees.